Imagine, just for a moment, that you could stand at the very edge of time, at the birth of the universe, not metaphorically, but physically present, somehow shielded by impossible technology that lets you survive the unimaginable. No heat, no gravity crushing you into oblivion, no radiation disintegrating your atoms, just you, floating in the darkness before time began. And then, it happens. The Big Bang. But what would it sound like? We often imagine the Big Bang as a massive explosion, a thunderous cosmic firework that ruptures the silence of nothingness. But that mental image, as vivid as it is also a little misleading. The Big Bang wasn't an explosion in space, it was an explosion of space. There was no center point blasting outward into a void, because there was no outside to blast into. Space itself stretched, inflated, and roared into existence, carrying all matter, energy, and time along with it. Still, let's entertain the impossible. Let's ask if there were a place to stand, and if sound could travel in the earliest universe, what would the Big Bang sound like up close? To answer that, we need to understand what sound is. Sound is pressure. Waves vibrating through a medium like air or water, carrying energy from one molecule to the next. But in the beginning, there was no air. There weren't even atoms yet, at least not for the first few 100,000 years. The universe was an expanding sea of plasma, hot, dense, and churning, noisy in its own way. And within this dense plasma, sound could travel. In fact, scientists believe the early universe did ring with sound, not the kind we hear with ears, but pressure waves, ripples in the hot plasma caused by tiny fluctuations in density. These waves bounced around the infant cosmos, shaping how galaxies would eventually form. Some call it the music of the cosmos. Now imagine you're there, not billions of years later with sensitive instruments, but right at the edge of the action. In the first few fractions of a second, the universe expanded faster than the speed of light. This period, known as cosmic inflation, was silent, because inflation outpaced the ability of sound to propagate. But once inflation ended and energy could interact again, all hell broke loose. Matter and radiation mingled, temperatures soared, and the density of the universe was extreme. Sound, in those first few minutes, wouldn't be the high-pitched wail of a siren or the bang of fireworks. It would be a deep, primal roar, so low and slow that it vibrated through space like a cosmic drumbeat. Think of a billion thunderclaps colliding, not once but over and over, in waves of unimaginable intensity. Astrophysicists have tried to simulate what those primordial sounds might have been like. The frequencies would have been incredibly low, far beneath human hearing. One physicist once compared it to a deep B-flat note, 57 octaves below middle C. That's a tone so low it takes millions of years to complete a single oscillation. But let's scale up this thought experiment. Let's imagine you could somehow translate those pressure waves into something your brain could interpret as sound. You'd hear a swelling cacophony, not just loud, but impossibly loud, louder than anything the universe could ever reproduce again. So loud that it doesn't even make sense to compare it to a jet engine or an earthquake. We're talking about decibels beyond comprehension. Enough energy packed into a single cubic centimeter to vaporize stars. And the noise wouldn't stop quickly. For hundreds of thousands of years, these pressure waves would echo across the newborn universe. That's right, sound wasn't a momentary boom. It was a symphony, a booming, bass-heavy hum that carved the very structure of reality, leaving fingerprints in the cosmic microwave background radiation, the afterglow of creation. But here's the twist, you wouldn't hear it. Even if you could survive the conditions, even if you brought along a microphone the size of the Milky Way, your ears would betray you. Sound, as we know it, requires ears that evolved under calm skies and quiet forests. They are not built to detect frequencies millions of times lower than a whisper, or to comprehend a wave that takes millennia to complete a single vibration. So, instead, the sound of the Big Bang becomes more than an auditory event. It's a concept, a pressure, a resonance of something far older than language or experience. a memory etched into the fabric of the cosmos. And when we point our telescopes into the depths of the sky, when we measure those ancient microwave whispers left over from the beginning, what we're really doing is listening. Listening to the echoes of that first vast chord, that original roar. So how loud would the Big Bang sound up close? Louder than anything you can imagine, so loud it would be silence. Because sound, at that scale, doesn't just travel, it becomes the medium. The cosmos itself was a speaker, and what it played was the first note in an endless, expanding song. And we, here on this small blue planet billions of years later, are still learning to hear the rest of the music.